Hi everyone, welcome to Megaport's Tech Drop-In Friday, the 28th of Feb. I am Mark Austin, a pre-sale solution architect at Megaport, based in Sydney, Australia. Today, we will be covering the options in regards to service resiliency. So when building services across the Megaport fabric, how do you build them in a resilient way? So I'll walk through some different overviews in terms of physical resiliency, but also logical resiliency. I'll then walk through a demo of how that's deployed in the Megaport portal. So getting started, I'll just jump straight into our Megaport docs page. So under docs.megaport.com, you can have a look at exactly the same information I'm looking at here. So under deployment scenarios, common connectivity scenarios, you can see here we have 8 different essentially physical layer connectivity scenarios. So they start from not resilient, so just a single connection, all the way up to geographic resiliency. And I'll walk through each of these. So scenario 1 here, you can see the red box is a data center. So that would be the 900 plus data centers you can connect physically to Megaport globally. You would connect to Megaport in one of those data centers, either using a 1 gig, 10 gig, or 100 gig interface. So you get a dedicated interface on the Megaport fabric. So this one here represents the customer rack cross-connecting using single mode fiber into a Megaport edge device. So that is a single device, obviously single point of failure. So moving to the next option there, option 2, we offer the ability to lag 2 or more, up to 8 ports, either 10 or 100 gig, together to create a logical Ethernet interface. So in this case, you can see the customer rack, they may be running something like virtual port channel or multi-chassis lag, and they want to aggregate interfaces together for added resilience, but also added capacity. So moving to the next one, option 3, you can see here, this is where we break out within a single data center to 2 separate Megaport edge devices. So what we refer to here, when we offer this in a data center, you will have a red zone and a blue zone. So essentially what that allows you to do is have 2 connections on 2 physically diverse devices. So moving to the next option there, option 5, this is where you move out into 2 data centers, so geographic resilience. This one here is showing a single connection into a fabric device in each of those data centers. So here you're benefiting from geographic resilience. If you would like to add to that, you can also extend, if you're in one data center, you can extend out to a different data center where Megaport is located to benefit from Megaport edge device resiliency. And this one here is just showing you can bundle those 2 ports together into a lag. So number 7 is showing the same thing, but you have the customer has a presence in both data centers, and they are doing multi-chassis lag or virtual port channel into the Megaport edge devices. And the last option there is showing probably what we see most commonly. This is the maximum level of resiliency. Within a data center, you're connected to the red device and the blue device, but you also have geographic resiliency built in there. So this is maximum level physical connectivity. So what I'll show next is moving out into the wider network. Under here, we have common multi-cloud connectivity scenarios. And this one here, number 1, is just showing once you are physically connected to the Megaport fabric, you then build virtual connections across the fabric either locally or globally, and we refer to those as virtual cross connects, so in short, VXC. And they are basically a point-to-point VLAN across the fabric between any 2 points. And in this diagram here, you can see the customer's presence, their presence in the data center is being connected to 4 different cloud on-ramps. So in this case, being connected to the private cloud on-ramps of the cloud service providers. So we move next to number 2. This is showing the same thing, but here we've added resilience through a Megaport lag port. The customer has 2 devices connected to 2 ports in a lag, but also the added resilience of additional VXCs to diverse cloud on-ramps. So moving forward to the next option there, option 3, what we're adding in here is what's called the Megaport Cloud Router. So the Megaport Cloud Router is a virtual device that runs on Megaport compute in over 100 locations globally. You don't need any physical presence to use the MCR, but in this case, the customer's presence in a data center is extended through to the Megaport Cloud Router. The Megaport Cloud Router is then connected using a virtual cross connect across the Megaport fabric to the cloud on-ramp. Number 4 is representing here the red and blue zone. So a customer device is connected through 2 different customer devices, one to red, one to blue. And from each one of those red and blue ports, they each have a VXC to the cloud on-ramp. So this is within a single data center, but you have full device diversity, full cloud on-ramp diversity. So moving forward to number 5, you can see here, this is completely virtualized cloud, basically multi-cloud connectivity, just purely cloud to cloud. But with the MCR, here we have 2. So the MCR has the option within a metro, at a minimum, we have at least 2 different geographic locations where you can host the MCR. If for whatever reason you would like to host them in the same location, they can be deployed, one in red zone and one in blue zone. So they are physically diverse. But general recommendation is to deploy the MCR in 2 different geographic locations. And each MCR in this topology is connected to the cloud on-ramp. So this is a fully HA design. So number 6 is adding to that, extending to the data center. So you can see here the MCR, each one of the redundant MCRs is connected through to a red port, so red diversity zone and the blue diversity zone. So this is a complete HA design. So there's really here no single point of failure. So number 7 is breaking this out into 2 different data centers. So a customer is in 2 different data centers. They are using Megaport to connect to the cloud on-ramp. So each one of these ports has a virtual cross connect to the cloud on-ramp. But here we're just benefiting purely from the geographic diversity of the 2 data centers. And number 8 is an extension of that, adding in the MCRs. So the MCRs would be in 2 different geographic locations, adding to that resiliency, and each MCR would have a virtual cross connect to the cloud on-ramp, but also a virtual cross connect to at least one of the data centers. If not here, you can see an optional virtual cross connect to the other data center if you wanted that added resilience. So number 9 is really adding the maximum level of resiliency here. So 2 different data centers. Within the data center, each device is connected to a different zone, so red and blue, and each port is, a red port in this data center is connected to MCR1, the blue port in this data center is connected to MCR2, and likewise for the other data center. So this is the maximum level of resiliency that can be attained. So I'll stop there with the options, and I'll jump into the portal and show you some basics of how that is deployed. Okay, so we're in the Megaport portal. We're going to create a port or create a diverse pair of ports within a data center. So that's a starting point. We will, I'll just log out of here, the wrong place. Okay, so I'll jump onto the services page. I'll kick off creating a Fabric port. Let's create this in Singapore. So you can see here the data center list of where Megaport's present in Singapore. Let's select Equinix SG1 as the location, and we will select port speed of 10, and we'll just put in their name live demo, port 1. Okay, and you can see down here we have the option of port diversity. So we want to deploy two cap connections in that data center, each on one on a red and one on a blue. So we want to create a diverse pair. So you can see here the first port name, I'll add in the second port name, port 2, and we will go ahead and add those. And you can see here, as part of I haven't ordered it yet, but as part of the design phase, you can see here, port 1's diversity zone red, port 2 diversity zone blue. So one thing I will explain, which is sort of critical, is that these diversity zones essentially are local to the data center. So what it really allows you to do is to have two services in a data center, each on two different zones. So when you're avoiding obviously device failure, but you also when Megaport carries out maintenance work on the infrastructure within a metro, the general way that maintenance is carried out is at one point in time, maintenance will be carried out on devices in the red diversity zone, and then at another point in time, the devices in the blue diversity zone. So we do recommend customers try and align a primary topology to the red zone and a secondary topology, say, to the blue zone. It's not a hard and fast rule in all scenarios, but just as a general guideline across the network, try and align, part of the primary to the red and the secondary, say, to the blue, or the other way around. So I'll go ahead and order those. And then I'll just show you the steps to deploy an MCR or geographic diverse MCR. So the options with MCR, you can see here when we type in Singapore, we show the list of locations that you can deploy an MCR on Megaport compute, which is located in these locations. So you can see here in Singapore, there's way more than 2 locations. We've got at least 7 currently that you can deploy, and they're all equally the same in terms of technical capability. So there's no reason to you can choose any of these. That's fine. So in our case, since our ports are in SG1, let's just choose that one. And you can see here, that's for the first MCR, we'll do an SG1. But you can see here, you've got an option of red or blue. Okay, so we want to align this to we'll connect this MCR to the first port, which is red. So let's do this in red. Okay. So let's choose the throughput of the MCR. And the name, and we'll just go ahead and deploy that. Okay, so we're deploying the Megaport Cloud Router at Equinix SG1 in the red diversity zone. So we'll add a second MCR in Singapore. So we want to make that in the blue zone. So these are the blue zone options. Let's choose SG2, which is a speed. And next we'll add the MCR. And let's deploy that. Okay, so we've got MCR1 in red, MCR2 in blue. Let's link the ports to the MCR. So port 1, let's connect that through to the MCR. So we'll use a private VXC for that. You can see the list here. So we want to link that to the red MCR. We'll call this VXC1. We'll make it a gig. And that's that. We need to assign an IP address to the MCR interface. And we'll add that VXC. So the next step is from port 2, which is in blue diversity zone, we want to connect that through to MCR2. And okay, MCR2, also in the blue diversity zone. VXC2, we'll make it a gig throughput, assign an IP address to the MCR interface. And deploy that. So what we've got currently is port 1, which is in red, connected to the MCR1, which is also in red. So like I was saying earlier, even though diversity zones are a local concept to the location, we advise to align say a primary side of the network to one zone and the secondary side to the other zone. So in this case, port 2, which is in blue, connected to MCR2, which is also blue. So the next step here is from each of the MCRs, I'm going to connect it to AWS Direct Connect. So what we'll do here is we'll select cloud, okay, and for the VXC type, AWS, we will select, in this case, hosted connection. So there are two different types of AWS Direct Connect hosted connections. The hosted VIF option was an earlier option. It doesn't allow you to choose a specific diversity zone. Hosted connection allows that. So for this one, the MCR is in red, so we'll select also the MCR in the on-ramp in red. So you can see here, SG2, red on-ramp. Click next, we'll call this AWS VXC1, select 50 meg for this throughput. We need to assign an IP to the MCR interface. So this is one end of the connection to AWS. And I will just get the account ID. Okay. So we will go ahead and deploy that VXC. So I'm not showing all the steps here. The additional steps would be configure BGP peering to AWS, configure BGP peering between the MCR and the on-prem device. But the purpose of this demo is just to show how you align diversity zones across the network topology. So you can see here off MCR1, we've added the AWS hosted connection VXC, which is connected to the red zone on the AWS side. So we'll add a second one off MCR2. So again, AWS hosted connection, and this is blue. So you can see here, that's shown as the option. AWS VXC2, speed of 50 meg. Again, we'll add an IP address on here on the MCR interface. And deploying that. So the next steps would be to, within the AWS console, obviously accept those connections, configure the virtual interface on the AWS side, and BGP would come up at that point. But what we've done here, in summary, has built out physical connectivity from a data center, so diverse physical connectivity, so a connection in the red diversity zone, connection in the blue diversity zone. We've deployed the two MCRs in two different geographic locations, but we've also aligned the diversity zone of those MCRs to the diversity zone of the connected port. So say during maintenance within a metro, it's less likely that you will come across, say, the primary path of the network being interrupted by maintenance or a maintenance event. So that's the general recommendation. And then building out the cloud connectivity, we've aligned, in this case, the AWS diversity zone with the diversity zone of the MCR. So keeping that diversity zone aligned across the network. So that completes the live drop-in for today. I hope that was helpful. If you do have any inquiries with Megaport, please reach out and we will walk you through the Megaport product set. Thank you.